Good morning, everyone. I'm Agalya. I'm a quality analyst at ThoughtWorks, and I have Abinaya with me today. She's also a QA at ThoughtWorks. So we are going to present a section on how to Dockerize your test. So today we are going to cover basics of Docker. We're going to talk about the Docker object, what is a Docker image, what's a Docker container, Docker file, and we'll also see finally we'll see a demo on how to use Selenium to run your tests, Selenium tests in your Dockerized container.
How many of you are familiar with Docker here?
Part of it works, yeah. But you not work.
Not And Selenium? Almost all.
So many devs, how many QAs?
QA.
Most of you are familiar. Right.
What is Docker? So Docker is the open source tool. It's primarily used for automating the deployment of the applications. So right from installing your software, installing your application code, so you can go on to creating your complete environment for you to up and run your application. So why Docker? So we all write programs, right? Whenever we write any test code, it will work perfectly fine in our machine. The same code, you change nothing. When we try to run it in a CI server, it fails. Most of the time it fails. Because the environments are different. They are all the same. The code remains the same, but the environments are different. So shipping code to the server, it shouldn't be too hard. If it passes in your machine, it should pass everywhere. So if you're running it in your machine, it should pass. If your colleague runs the same shit, it should pass. If you're running it to the CI server that's hosted on a virtual machine, it should pass. Because of the environmental differences, right? We're spending a lot of time to fix it. So here comes Docker into the picture. So Docker gives you a way to package your software into a box. So with Docker, you're not just packaging your code, you're also packaging the environment. So irrespective of wherever you run it, you can run it against your production server that's hosted on a cloud, it's going to run the same. You run it against the QA server that's in the virtual machine, it will be the same. It will spin up the environment, it will put in all the codes. So it guarantees that it will always run the same wherever you are. So how many of you have used virtual machines? VMware, VMware Fusion. So virtual machine does the same thing, right? Yeah. So what are the drawbacks you guys face with virtual machines?
Connectivity issues.
Connectivity issues.
The performance.
Yeah. By looking at this image, we could say Docker is Docker containers are very lightweight. So when it comes to virtual machines, so each of the virtual machines they'll have their own guest operating system running on, so which will consume like tens and tens of GBs. So in a single machine, even in a high power machine, you cannot have more than 3 virtual machines running. That's not the case with Docker containers. You can easily spin in more than 10 to 15 containers in a single machine. Everything can run parallel, seamlessly. No performance issues, nothing. So for you to boot up your virtual machines itself will take 3 to 5 minutes, right? Dockers can just boot up in seconds. We'll also show it in the demo, how easily it spins up. It takes a lot of time. So Docker is not going to use any separate operating system. It will share the host of the kernel of the host operating system.
Does it mean that it's going to replace Docker is going to replace? It's only for testing.
No, even for the application, you can create a complete environment. So virtual machines is one of the options, but the drawback is like memory consumption, slow. With Docker resolves all those things. Afford to have so many physical machines. It's going to cost you. You have to maintain all those things. That's going to be a problem. With Dockers, you can build Docker images, and you can have all those images in a single machine. So whenever you want to run your test in a Firefox 45, right, just spin up that container, run it and kill it. It's not going to consume more than 1 GB of space. So it is high. So we have browser stacks and other things doing that, but again they are licensed, so they are going to cost you money. But with Dockers, with available resources, right, you can achieve cross browsers with multiple browsers.
So what do you do for IE?
We have we have Windows containers. When they started, they didn't have it. They had only Linux containers. Now they have Windows containers as well. From Windows 8, we have it.
Okay, Windows 10 and Windows.
You can easily parallelize your disk. You can set up your hub, Selenium hub, and your Selenium node. You can have everything in a machine. At a time, you can spin up 5 containers. It runs. It's really helpful in parallelizing your disk. And one of the major advantage the Docker gives is with the component reuse. So we'll just see how virtual machines and Dockers are different. Again, say for us to run your test, you need a guest operating system. Let it be Linux, and Java, Selenium, your browser. So all these virtual, you have to install everything in each of the virtual machines. Even your application code, right? Say you're building an enterprise system, you have 50 developers in your team. So in the world we are not having the Dockers. Each and every developer has to go and manually install Java. Say you need a Postgres database. Each one of you have to spend this much time. So the automation of those things you get it with that. And the component reusing. So in virtual machines you cannot reuse anything. So each virtual machine has to run its own software, the operating system, Java, everything. When it comes to Dockers, you can have your base image. Say what will be the base image for us to run your this? We need an operating system, we need a Java, and we need Selenium. That's going to remain same irrespective of the browsers. What we are trying to achieve is we just need the variations in the browsers. So when you build a Docker image with all these things, it will just come to 1 GB, even less than 1 GB. So whenever we want to install, say, Firefox 45 on top of this, it will just consume a little over 1 GB. So you have 10 Docker images in there. It's not going to consume 1 into 10 is equal to 10 GB. It's not. It will consume only a little over 1 GB. It will reuse the base image. It will not create base image every time whenever you run. So the existing base image it will reuse. Only the difference in part, right? That is the extra space is going to take. So this is one of the major advantages that we get with the Dockers when compared to the virtual machines. Yeah. When you have a Windows laptop, you can install Docker for Windows, and you can so this will run on a virtual machine. The Docker containers, right? Only one. The Docker will run on it, and then it will spin in its own. Version control. Say we have Selenium 3. You have 10 agents running your test. When you want to upgrade to Selenium 3, you have to go and upgrade it manually every day. And then you have to upgrade your Firefox version 7. So manually you have to go and upgrade it every time. Right? But here, so how many of you have used Git? Yeah, similar to Git, right? Docker gives you the facility where you can, so it has this successive label. Each comments Git will maintain, right? Similarly, Docker will also maintain. So you just go and put a comment saying like upgrade my Firefox version to this, and you run it in all the agents you have, it will just do. You're going to update it only once. And if something fails in that, you can roll back to the previous comment. You can quickly create your environments. You're going to create all the environments with just a single Docker file. You're going to update it. So it's just one time. All the systems will be consistent since they are all going to be created from a single file. It is going to be consistent. Any questions?
You continue. So Agalya was saying about, she was using different terminologies, right? She was saying containers, images, and Docker. So let's see what are those, right? These are the common terminologies that you come across when you start using Docker. So, so Docker engine, the one at the top. So it is the one which does all the management of images, containers, and all. So that is the one which I have. Next is the images. So image is nothing but it's just a file system, and it would contain all the parameters that you want to run, and it forms the basic of any container. So if the container wants any information, it is always present in the image, right? So it is basically, as it says, it's a snapshot of the container. So it would say what the container would contain. So it would say, okay, for example, I want this particular OS, for example, Linux or Ubuntu. I would say Ubuntu there. And for example, you want to install Selenium and Firefox. So you would say install Selenium and install Firefox just as you doing a normal thing. So it will contain all the softwares for the container to run. Let's see how to get an image. Okay? So we know that what is an image. Let us see how to search an image. Okay? There is something called as Docker Hub. It is nothing but a repository, a central repository, where the pre-built images are present here. So it helps you to share your images, distribute your images. So if I create an image, I put it in this Docker Hub, someone else can access it. So there are different images available. You can make it public, you can make it private, you can make it official, and there are also commercial images available. For example, I'm searching for an Ubuntu image. So this lists down all the images related to Ubuntu. Okay? Here it says it's an official image. And you can always see what are the stars and how many pulls people have made to this this particular image. And this is if you had used Git, this is no similar. This is very similar to GitHub, wherein you push all and it maintains all the code. Just similar to that, it is a storehouse of the images, where you share, create, and distribute your images, right? I can show you the details. For example, I search for Selenium. So there are different images. I go to one. Okay. So this would say what are the details of this image, what does this image do, how to run the image, and so and so. You can also see how to pull this image. This is similar to your git pull and the repository, right? This is very similar to that. And you would see who the owner is. So one cautious thing that you have to make a note is, make sure that you pull from an official image. There will be multiple images hosted by different people. Make sure that you pull a license, an official image, and which has lot of pulls and lot of stars, which people have used it and confronted that yes, this is good and this is useful, right? So the owner is Selenium here, so for sure you can go ahead and pick this image, right? This is how you search in the Docker Hub. You can also search it from the command line. Is it visible?
Yeah.
Yeah? Right. So I say Docker here, which means I have already installed Docker in my machine, right? Docker, I say search. Okay. Docker search, and I search for Ubuntu. So this would give you the same results as you saw in the website. So it would say what is the name of the image, the description, and the number of stars that you got, and whether it's officially okay or not. And this is their deployment. Okay? So you can search for an image like this. So now that we know how to search for an image, let's see how to pull an image. Okay? For example, let's pull this Selenium hub, okay? I use the same command, the docker pull Selenium hub. So what it says is, it says uses the latest tag default. Default tag is latest. So for every image that you create, you have a tag. And by default, it would pull the latest tag. That's why it is looking for the latest tag and trying to access it and pull it. Okay. So what is it doing is, it would so it would go ask Docker Hub that see whether the Selenium Hub image is available and pull it. So it is looking for the latest version of Selenium Hub. As you can see, these are different layers. So all these belong to specific commands which you give. So each and every command that you give in the Docker file would be a layer here. So Selenium, the Docker works in the layered architecture way, right? So you can see that it checks whether this is already present. If so, it does not download. And you can see that it has also pulled few things, right? Pull complete. It was downloading. So it downloads only the required pieces. And it builds a layer at the top. And then once all this is done, it would delete the existing things, right? So it would build temporary containers and there. And then when all are done, it will delete the temporary. So now which you get is the Selenium Hub image, right? This is so you have pulled this image. Let us see how to list all the images that you have. So the image which I have pulled, Selenium Hub, is now sitting in my local. Now I would say Docker images, which would list down all the images which is present in my local. Right? So these are the different images which is present in my local. It would say details on what is the image on, what is the tag. So if you don't mention any tag, it would be latest. We can also specify different versions. For example, I want to pull Ubuntu 14.0. You can also specify that, right? And for each and every image, there is an image ID associated with it. That is what it says. It uniquely identifies your image. Okay? And you can also see when was it created, whether it's the latest image that I have, or do you have to pull more. And it will also say what is the size of the image. So these are the different information that is available for an image when you see Docker images. Okay? Any questions so far? Good? Alright. Let's move on. Yes, we have found the Docker images. Next is Docker containers. So now you have pulled your image, okay, and you have your image ready. When you run this image, the one which you get is the container. So it is nothing but the running instance of that image. For example, you would have learned in OOPS concept. There is a class and there is an object, right? So you can compare the image to be a class, and the running instance of the class would be a container. So the running instance of the image would be container here, right? Can you make the analogy? Image when run would give you a container. So now we have pulled this image. Let's run an image, okay? I would say Docker run. I can say Ubuntu. I'll run in the background. Yes. So when I run this, it gives me an ID. So this ID is the container ID. Okay. Similarly, how you uniquely identify an image using an image ID, you have something called as container, and you have ID associated with to uniquely identify. So whenever you build an image or run a container, you can also name it. You may not have to remember this ID. You can always tag it. You can say Ubuntu, Abinaya Ubuntu. Maybe. You can say a tag, right? And it would uniquely identify your container. So this is how you run a container. As we saw how to list the images, when you say Docker PS, it would list down the containers. Docker PS would list down just the active containers, okay? And a container would be active only if there is any process running in it. For example, these are, right, you're confused. We just ran a container. And when you list down the containers which are active, it is not present. It's because it does not have any process. So container is alive only when there is an active process associated with it. As there is no process, it just starts and then sees, okay, there is no process, I kill myself, and it dies. So Docker PS would give you all the active containers. When you say Docker PS-a, it would give you all the containers that I've created long before. So if I can show you, okay, it says container ID. Yes. Visible? Yes, right? So it would say the container ID, what image it used, because the container came from an image. So it will say what image that it used, the command, and when was it created, the status, whether it is created or it exited. There are different status that a container has. It can either run, it can either stop, it can either be active. So there are different status, and it would have ports in case if your container is exposing a port to the the host of the Docker, in which in my case it is the machine. It's my local machine, right? So it will list out the ports also. These are the different informations that you get when you look for containers. Cool. Right. Now we know what is an image. What is a container? As I said, a container is the running instance of an image. Just like how you can create multiple objects from the class, you can create multiple containers from an image. So you can have the same image, but you can create multiple or spin multiple containers from one image. Yes, these were the few Docker commands which we saw. We searched Ubuntu, we pulled, we saw images, we list down containers, active containers. So there is something also called as logs, which you can see, okay, what is actually happening in my container. If you want to see, you can always use Docker logs, okay? Because your container would perform some actions, but you cannot see it. If you want to see or know what is happening inside, you can use Docker logs. And so you can create a lot of images, right? And it, as you saw, there is size associated with each image. And you don't want your machine to be filled with images which you're not using at all. So you can also remove your image, you can also remove your containers, right? So these are just few commands. RMI is the command which removes your images. Okay? You can say RMI and the image ID, it would remove that particular image. Yes.
But like, you told only active containers will be using the RAM.
Yes.
So you find all those not active containers as well. Will those be using memory?
No.
Containers will not use in the images will still continue. So that will
As a file.
As a file, yes, that would be available. If you want to remove this, you can.
Consider as the program you have downloaded, so that was going to bring in the runtime.
So now we know what is an image, and you run, get a container. So for this image, we were depending on Docker Hub for now, right? We were getting all the images that we want from the Docker Hub and using it. What if we want to build our own image? What if I don't have what I want in the Docker Hub and I want to build my own image? So there is some file called Docker file. It is nothing but it is a file which contains all that you want to build an image. Okay. For example, consider that there is no Ubuntu OS available. I mean Ubuntu image available in Docker Hub. I want to build my own image. So I would say that use this OS and consider that there is no Selenium available on this particular OS. Add my Selenium jar. Okay. So all the things that you want to do in an image and run a container would be present in a file called Docker file. Right? That would make up your image. So now what you have is you have your Docker file. How do you get your image? You build the Docker file to get an image. Okay? And when you build, you get an image. You run, you get a container. So this on a summary, this is the one which is happening in the background. You have a Docker file, build, you get an image, run, you get a container. Okay? Now, let's run a test in Docker container.
Abhi was talking about spinning up multiple containers, right? This will be really useful when you want to parallelize your test. say it's enough if I need to run my test against Firefox 45, but I need 10 machines running Firefox 45. You can have a single image with all your record software in the products Firefox. Using Docker Compose, you can spin in any number of containers from the same Docker image. Still, it's going to consume the 1 GB, but you can spin in any containers that is up and running your Firefox. Yeah. Now let's see how to build our own image for running our Selenium tests in the. So what do we need for us to write and run our Selenium tests? What are the softwares?
Eclipse.
Okay.
Programming language.
Browser. Language. We need operating system. Now let's see how to install everything in the Docker. So you have to create your Docker file without any extension, dcat, and rest all smaller keys. Docker would expect it to be in this case. This is like a syntax. Without any.
So it should be inside your project. It's not equal.
Yeah.
Yes.
You can.
The folder where you want your image to be.
So I'm going to use Ubuntu as my operating system. So I'm going to say from. This from is the Docker command. Okay. So Docker from command will tell you what is your base image. So on top of this, we'll build other image. So now I have my base image. Okay, now I'm inside the Selenium Docker demo. Okay, now let's try to just build this one. The command is Docker build. Okay, I'm going to give a name for this. Put this Java Selenium and then Docker. Where my Docker file is situated inside my project folder. So this is the current folder, so I'm just giving it. So I already had Ubuntu, so she downloaded Ubuntu, so I didn't pull it again. So it says as we have the Ubuntu running for this. Now let's try to install the Selenium into it. So the Docker run command. So this Docker run command, what it will do, it will execute the shell commands to install the programs in your Docker container. For us to download the Selenium, we need wget. I'm going to use wget for this. This will do a wget update. I need wget. I'm going to use wget to get my. So if you're not sure of the shell commands, you can very well Google. So how to install Selenium in a Linux box? You just Google, right? You'll get these commands. Okay, now we have wget. So we'll try to build this. So it's just pulling the wget first. It's going to update the wget and
So that Ubuntu is installed, it doesn't have WPC.
yeah, we just had wget and this is a base image.
It just has the basics.
So now I have my wget, wget. So I'll use the wget to install my Selenium. So where can I find my Selenium? I'm going to pull it from the Google APIs. So this is the URL, and we have a lot of versions of Selenium, right? We can see we'll download the Selenium 2.5. So I'll take this URL and wget. And then I'm going to download 2.5. So I'll copy this. still pulling my. No, you don't get a Ubuntu UI, but there are a lot of containers, ready-made containers that are available. It comes with a PNC server, just in case you want to see how your test runs. Right? It comes with a PNC server, and they have exposed one port. So while running your test, you can ask your Docker to listen on that port, and you can view it. That will be showing it in our demo, because everything runs in the background. If you want to show it, we're going to cover that. Okay. I did not use hyphen I used it.
So hyphen Y, the reason why she gave was to say, okay, so whenever you install it, asks you, okay, whether you want to continue. It would ask you to say yes or no. So if you want that to happen in the background, you just specify hyphen Y and it automatically answers the question.
Windows images, they won't be created. Or not yet.
So there is Windows image. So initially when they started, they were not ready, but then yes, they started giving the Windows image. We have not used, at least I have not used the Windows image.
I think we have private images.
Yeah.
So we can install this Docker on a Windows machine also, right?
Yeah. It's just that you have to have your Docker installed on your Windows machine, and then so you would have, just like we have Mac, it would have Docker for Mac. Similarly, you have Docker for Windows. Please install that, and you'll be able to install other OSs into your Dockers.
The instructions, and it's different for different versions of Mac. So if you have a latest work, you don't need the Docker toolbar. So the installation instructions are there. But they are readily available in the kit. When I run it the next time, right? So we had added the shell command to download the Selenium, so it's doing that. So wget it's installing the Selenium. So we'll just quickly go back to the slides. So this is how you have to build your own image. So this is a sample Docker file for installing a Java Selenium on the Ubuntu OS. So you can see Docker from command, as I said earlier, you're going to tell what is my base image. It could be anything, it need not be Ubuntu. So when you have something with the Ubuntu or Java pre-installed, you can just very well say my base image is going to be that image. It need not be from the Docker hub even. You can even give your own images as a base image. And the Docker run command, as we said earlier, is going to execute the shell commands to install your commands. So you see, I have changed my commands with Android. So do not have so many run statements in your Docker file, because for each of the run statement, your Docker will create one additional layer. So each layer is going to be associated with a file. So the more the run statements you have, the larger the size of your Docker file. So try to change your comments whenever possible. Just the double ampersand. So for installing my Java, I just needed some extra packages. So you can, when you search in the Google how to install Java and Ubuntu works, you just get these and and the env command, the Docker env command. You see this? You can set your environmental variables. So for us to run Java, we need to set the Java home, right? Just put env Java home and give your path. It will do it for you. And again the run command, I'm using the run command to install my Selenium. and Firefox is the command to install Firefox, and the work directory. You can also specify your work directory. Say you want to run your tests, you will always run your tests from the test directory, right? You can specify my work directory is going to be wtest. So whenever you want to run any commands, this will be the default directory. And also if you want to expose any ports, right, there's an expose command. You can say expose and you just expose one port for any of your operations to this. So these are the few basic ports. So for our demo, we'll try to pull in an image that is already available in the Selenium Docker hub, and we'll try to run it. That's how we'll do. So these many images are available. So the Selenium official site, right? We have these many. This is the Selenium base image, which is just has a Java runtime environment and a Selenium Java. And hub. If you want to parallelize your hubs, we have a ready-made Selenium hub available. And for that hub, you need a node, right? So you have a node Chrome, you have a node Firefox, and you don't want to parallelize, you have a standalone Chrome image for that. And as you said, if you wanted to see how your test runs, right? You have the debug images. This comes with a VNC server enable. So you can have a VNC viewer in your machine, and you can run your tests in the container. Still, you can see what's happening in this. So Chrome debug. You can have you even have the node images that could be used for parallelization with the debug. So these are the official images. Really available. You do not do anything, just pull and run it. Now I have my Java Selenium. So you can build your own images. On top of this, if you want to install multiple versions of Firefox, you can have this as your base image and just give the Firefox command, and the rest of the Docker files just spin it up. So whenever you want to pull or run an image, right, you just check whether that image is readily available or not. If it's available, it will use that image. Otherwise, it will go and check for the image, it will download the image, and then it
Uh, yes. So we shall download the image to get the browser with Selenium, and then we shall write the test and see how to run the test against the container which is running. Okay. So what we'll do is we'll just use this command. So this is how I run. And so there is this image, right? As Agalya showed in the Selenium page, the image which contains an OS with Selenium and Firefox. So what I do is I say Docker run, and this -d says that it has to run in the background, and this -p is just the port forwarding. So for example, our Selenium servers run in 4444 by default, and it would run in the container. But I want it to be exposed to my local machine. So I say expose 4444 of my of the Selenium port in the container to 4444, the same port. You can use any other port if you want, and this would be the port of my local machine. Okay, and I am pulling this image. So what it does is, when you say Docker run, it would see whether you have your image in your local. Sees if there is one. If not, if there is one, it would just go and run a container. Else, it would go to the Docker hub, pulls the image, and then runs the container. Two process. So it says unable to find the image locally. Now it would go and start pulling it from the hub. So it says it is pulling it from Selenium standalone Firefox. So these are the layers which the Docker already has in the machine. So it just pulls the one which it wants, right? So now it is trying to pull a standalone Firefox. I have so it will complete. So what we'll do is we'll just use the image which I've already pulled. Okay. So there is the standalone Chrome which is readily available with me. So when you run this, yes, this is your container which is created. I ran it second time, that's why it's saying an error. But then yeah, this is your container running. Okay. Now we'll write a test. So yes, this will be a simple test scenario. We'll just write a simple Ruby code. Okay. We'll just instantiate a WebDriver. We'll go to the Google page, search for some word, and then we'll see. We'll just take a screenshot and save it. Right? This is just a simple flow. We'll write this test scenario and run it in the container. Yes. As you can see, there is no screenshots available with me in the folder. Yes. So what it does is it creates or instantiates a WebDriver. A small trick here is you'll be using a remote WebDriver. Why? Has anyone used remote WebDriver? No? Okay. So when you use remote WebDrivers, when your WebDriver is not present in your local. Here, our Selenium is running in the container. Okay? It is not in your local. So that's why you go for a remote WebDriver. So it is nothing but it would access it would be just like running your tests in container. So the WebDriver would be somewhere in remote. So you say remote WebDriver and you say it is the Chrome which I'm looking for. And yes, you would instantiate this WebDriver saying this is the URL. So this is just the syntax for calling a remote WebDriver. This port, right? This is the local host, the machine which I'm running in. And as I said, I had exposed the Selenium port to 4444 of my local machine. That's why I'm saying this is my port, this is my IP, followed by my port. This is how I get access to the container, right?
We have a Docker container running in your local, so we have put it as 000 localhost. If you're running it against any agents, right, just put the IP of that agent.
It is similar to Selenium build, right?
Yeah, similar
Yes,
to
Selenium build. The container, the IP of the image where your Docker is at. Right? So yes, this is my setup. This is a normal test. I would just go to this website and then click on the search field, type hello world, and then just take a screenshot. So this is just one of my tests, and there are similar tests which would search for different words. So very, very plain test. Let's run this. So now my container is running. I'll go and run the test, okay? So as you can see, the test is getting executed. I've just added print statement so that you can see the test running.
So we have just used the standalone Chrome, not the debugger feature. That's why.
Yes. Okay. So this is a normal standalone Chrome without any debugger, and it runs in the background in the container. Okay. So adding on to that, you can also see what is happening in the container. You can see Docker PS. Okay. Let's see Docker. Alright, I'll show you the log meanwhile. So you know that the tests are running, right? And you could see the screenshots. The screenshots which we took after running the tests. These were the screenshots saved. So all this happened in the background. What if we want to see the browser running live? Okay, as Agalya was mentioning, we use something called as VNC server, and there is something called as debug. So when you use Selenium Chrome along with the debug mode, that image which is readily available, and you have a VNC server which will already give you the VNC server. And the only thing you have to do is install VNC client. Okay, let's run in that mode. I'll just delete the images. So I'll just say I have already I have this image in my local. So I would say Selenium Chrome debug. Okay. I'll stop all the containers before that. I can say Docker stop. This would stop all my containers. Now I would run
The default standalone Chrome, whatever we get it from the official directory, they'll be exposing 5900 port number in the VNC. So we'll just port forward that and try to come.
yes. So this is the port of the Selenium, and this is the port of the VNC server. Okay. So I'll just run the container exposing the ports. Okay, after running the container.
So local host 5900.
I'll run the container. And this is my VNC viewer which I have installed to see how my tests run. Okay. And I'm giving localhost and 5900, which is the port which we have exposed. So it would start your VNC viewer. Now I would run the same spec. You can see a test running in the VNC viewer. Now, your tests are run now. So your test is complete. So we saw how to run the test in the background, how to use a VNC server. We'll also look something called as Docker logs. So this is the container which is running, right? I would say Docker logs. So here you can see the logs with what happened in the container as such. So here you can see that it is the Selenium is getting executed on Linux. All the steps, you can even see what is happening. Okay, it is taking a screenshot. It is going to Google. You can see the logs what had happened in the container. What got actually executed.
You can be really useful when you're running your tests in the headless mode. You do not know what is happening. So you can even print this Docker logs into a file and it will be helpful for people.
These logs are printed by Docker or we are inserting?
No, we have to print it. Inside the container, this is printed by Docker. Just in case if you want to pull out and read it separately, for this.
You can just extract it out and move it to a log file and then use it. Any questions so far?
Can we add anything in the Docker log so that for debugging it will be helpful?
This is the default of the
Default. Anything we can add it? Just for
It should be possible. You should be able to add plugins for logging, and then those would come up there. Okay. Now, for example, you can use the plugin. I think if there is Logger, so there is Log4j, which is available in Java. So if you introduce that and introduce those logging statements, and those logging statements can be specific. You can say, okay, log just the information, or log the errors, or log the warnings. So, and you can specify, okay, which logs does my do you even want to see in the container, right? You can get those. This is how we run the test. So we saw that you can run a test in a container, right? Finally we saw. Now, what if there are multiple tests? Multiple tests, and you have hundreds of tests, and you want to run them parallelly. You know, Selenium Grid is one system which you can use for parallel execution. So you can also club Docker with Selenium Grid. As you know, there is a hub in case of a grid, which does the actions of splitting the tests across multiple nodes. In case if you're combining Docker with Selenium Grid, the hub and the node itself would be an image. Each of these would be an image, and you would split test the container that you would get out of running the hub image would split the test to respective nodes that you configure to. Right? This is a little advanced concept after using Docker, and if your test suite goes larger and larger.
Docker is a very old technology. It's available from 2005. Solar systems we have. So a lot of companies, the technical chains like Uber, PayPal, eBay, everybody has adopted Docker. So their environments are fully Dockerized. And Docker is based on a containerization technology. Docker is not the only tool that provides this container. So we have the LDX, we have Rocket, we have the OpenWiz, a lot of tools that follow the container technologies. So you can try out anything. We just went for the Docker. Multiple tools are available.
Why is it virtual machine or something like Docker? Why? It comes with the
Not sure.
You use Wine to run your Windows program on top of Linux. That's the purpose.
that's virtual.
You can't. It's
Why is WI?
it's like a sandbox thing. The application itself is kind of containerized, so that you can run your Windows application on top of Linux or Unix boxes. That's the idea. So you have Windows Visual Basic application you want to run on a Linux box, you can use Wine. And not 100% compatible. Not everything will not work on Linux.
You don't need anything extra. You need not learn anything extra for you to use Docker. Just a simple shell scripting is what it is. Put it in a Docker file, run it, containers will be.
And you can see how fast it is.
Yeah. So it just spins up the container and it took then 5 seconds. You guys didn't even notice it when you're running it. In the case of virtual machines, it will take 5 minutes to boot up the system and run it fast. It's pretty fast.
The only time where it takes is to download and get all the software, building an image. That's the only place where it takes time. And that's too, it's just the first time. And then you'll have it in local and you'll use it. And there are also advanced concepts like Docker Compose, wherein there are multiple containers, and if you want to link the containers, for example, there is a Java container, and there is a Postgres container, your DB container. If you want to link those two, you would use something called as Docker Compose. Those are little advanced concepts of them. Any questions? Thank you for joining us.
Thank you.
Please have your